Welcome to day 6 of the Advent of Code. Today our task is to count votes inside groups of members. What does that mean? For example, here is an example of our first group. A single person counted for or voted for A, B, and C, whereas in group 2 we have 3 people. The first one voted for A, B, C, and X, and the second and third guy voted Y and Z instead of X, right? But all of them voted A, B, C. And in group 3, we have 3 people voting for A, B, and C. Okay, so we're supposed to basically count the questions to which anyone answered yes. So here that would be A, B, C, X, Y, and Z. Here it would be A, B, C, and here it would be A, B, C. So my first observation was it doesn't really matter if a single person votes for A, B, C or 3 different people vote for A, B, and C. So the line breaks in those strings aren't really important, at least for part 1. Okay, so what could we do? We can simply put the entire string into a set. Sets get rid of duplicates, and that should give us a good starting point. Okay, so here's our example. If we put it into a set, we see, okay, A, B, and C only occur once. X, Y, and Z also only occur once. And then we have that pesky new line in there. How do we get rid of that? We can do that with the disjoin function. And what do we want to disjoin? We want to disjoin the new line. Disjoin is basically the opposite of conjoin. Okay, let's see if that works. Yeah, now the new line is gone. So backslash new line is what you would write as backslash n in single quotes in most other languages. Okay, and then we can simply count the number of characters inside the set, and we get 6. That's exactly what we wanted for the group 2 example. Okay, so we can abstract that into a function. Let's call it count any yes of some serialized form. Whoops, that's not correct. Of some serialized form. Then we replace the concrete example with a serialized form, compile it, and test if it still works. Yeah, still works. Okay, so that was rather simple to make it work for this example. How do we now fit this into the entire program? So here you can see a long string with single new lines for the members inside the groups. And sometimes we have double new lines. Those separate the groups from one another. Okay, so maybe let's simply split at the double new lines as we did 2 days ago, and then we have this persistent vector with the strings that we can now pass to our count any yes function. So let's simply map the count any yes function over it, and then we have a nice lazy sequence of those counts. And what are we supposed to do with those counts? We have to sum them up. Okay. Unfortunately, there's no sum function in Clojure. Some functional programming languages have that. What we can do instead is reduce that lazy sequence with the plus function and an initial value of 0. That simply means we are going to call the plus function with 0 and the first element, and then we are going to call the plus function on that and the second element, and then we're going to call the plus function on that and the third element, and so on. Right? That should do exactly what we want, and we get about 7,000, and that's the correct result. Okay, cool. So that was rather straightforward. Now in the second part, we have to look a little bit closer, because now the description changes from anyone to everyone. Okay, so for example, here in group 1, everybody voted for A, B, and C, but in group 3, nobody voted on the same question. Okay, and in group 2, everybody voted for A, B, and C, but X, Y, and Z was not voted upon by everybody. Okay, so now the line breaks inside the groups do play an important part. Okay, so maybe let's start playing again. So here's our initial input. Yeah, so let's split at the line breaks. That seems like a good idea, like this. Okay, and then we can map the set function over the elements in the vector, right? We want to count, or we want to put abcx in a set, abcy in a set, and abcz in a set. So let's map set over it. There we go. That's looking good. And now we want to basically compute the intersection of those sets, right? We want to compute a set that contains the elements that are contained in all of those three sets. And we have a function that's called set intersection. And unfortunately, it doesn't do anything because we did the classic mistake as yesterday. We don't want to pass a lazy sequence to set intersection. We want to pass the three sets contained in the lazy sequence. That's why we have to say apply set intersection to the elements contained in the sequence. And then we get ABC. That's correct. And we can count it. Okay, that would be 3. Okay, so now let's abstract. Let's say count all yes, serialized, then replace the concrete example with a parameter, compile, and check if it still works. And I have too many closing parents. Okay, so 3 is correct for that example, so that works as well. Okay, so all we have to do now is replace the any with all down here, and then we get about half as much as before, and that's the correct answer. Okay, so in theory now we're done, but if you look at those two functions, they are quite different. I think that's interesting, so you can see, for example, the disjoint function. But it would be nice if they were more similar. For example, set intersection has a brother called set union, which would do exactly what we want. So we could simply copy paste the entire body over here and then just replace the intersection with a union, compile that, and then check. If we now call the any function again, we get 7,000. Okay, I think that's great because now once you understand any of those functions, you immediately understand the other one because the implementation now is quite similar. Okay, what we also could do is abstract the similarities into a third function. Why not? Let's do it for good measure. So we could say, how do we want to call it? I don't know, count votes or something in a serialized form. And yeah, maybe let's first do the copy paste blindly and then discuss it. So of course, in the abstraction, we don't really know which function we should apply. We want to apply set union or set intersection. So let's abstract over that and call it combine groups. Then we have to pass that function, of course. And then the body of count any yes simplifies to count votes serialized set union. And the body of count all yes simplifies to count votes serialized intersection. Okay, so maybe first let's test that with all, so we get a different output. We get 3,600, that's correct, and count any gives us 7,000 as before. Okay, so now you only have to understand the logic once, and it's only contained in your source code once. You just have this nice little abstraction here. So basically count votes is now a higher order function, right? We pass it a string and a function, and that function is then delegated to apply, which itself is a higher order function. And here we can see, okay, the only difference because count any and count all is which of those set functions we pass. Is it a union for any, or is it an intersection for all? Okay, so that's all for today. I hope you learned something, and I'll see you next time.